If you're worried about managing your servers, then stop worrying. All you need is Lambda. Lambda is one of the services that falls under the compute domain of services that AWS provides. Hi everyone, and I welcome you all to this video on AWS Lambda tutorial. Today, we will learn some of the use cases and other global aspects that are forecasted. So before we begin, please do like, share, and do not forget to hit the bell icon to stay updated on the latest tech content on Edureka's YouTube channel. And also, check out Edureka's AWS Master Certificate program, the link to which is given in the description box below. So today, we'll be learning what is AWS Lambda, features of AWS Lambda, how is AWS Lambda used, and a hands-on session on how to create a Lambda function. What is AWS Lambda? Lambda permits you to run the code without owning or managing servers. Users only pay for the compute time consumed. You can operate codes for nearly any applications or backend utility without administrations. Users upload the code and Lambda does the rest, which provides precise software scaling and extensive availability. Lambda even scales our applications automatically based on the workload size. It scales the application running the code in response to each trigger. So now let us see some of the features of Lambda. First, serverless architecture. It provides no server management and automatic scaling. In no server management, you do not need to manage the underlying infrastructures, where AWS handles the administration of computers' resources. Lambda automatically scales your application by running code in response to each trigger, scaling precisely with the size of workload. Event-driven execution. It triggers and customs event source. Triggers. So here, the Lambda functions can be triggered by various Lambda services such as S3, DynamoDB, Kinesis, SNS, CloudWatch, API, Gateway, and more. In custom event sources, you can create custom event sources to trigger Lambda function from your applications. Next, function as a services. It considers microservice architecture and single function deployments. In microservice architecture, it allows for the creation of highly decoupled, independently deployed units of logic. In single function deployments, deploys individual functions rather than entire applications, making it easier to update and maintain. Next, flexible resource allocation. It has two things: configurable memory and execution timeout. You can allocate memory to your Lambda function from 128 MB to 10 GB in 1 MB increment, which in turn affects the available CPU power. In execution timeout, functions can run for a configurable period from 1 second to 15 minutes. Next, integrated security. It has two types: IAM permissions and VPC integration. In IAM permission, it uses AWS IAM to manage permissions and control access to AWS services. In VPC integration, the Lambda function can be configured to access resources inside your VPC. Next, development and testing. It consists of multiple language support, local testing, and AWS toolkit. In multiple language support, it supports various programming languages including Node.js, Python, Java, Go, Ruby, and .NET Core. In local testing, AWS SAM and SAM CLI provides local environment for testing Lambda functions before deployment. AWS Toolkit. Integration with AWS Cloud9 IDE and AWS Lambda Console for development and debugging. Cost efficiency. There are two things: pay as you go and fine-grained billing. Pay as you go, its charges are based on the number of requests and the duration of a code execution with free tier availability. Fine-grained billing, here it is built in increment of 1 milliseconds of execution time. High availability and fault tolerance. So it consists of built-in fault tolerance and automatic failover. In built-in fault tolerance, Lambda function runs your functions in high availability compute infrastructure across multiple AZs, which is availability zones. Automatic failovers. In case of failure, Lambda automatically retires and scales. Monitoring and logging. It consists of CloudWatch integration and AWS X-Rays. In CloudWatch integration, automatically logs all requests handled by Lambda to Amazon CloudWatch logs, providing visibility into function execution. In AWS X-Rays, it provides deeper insights in performance of your Lambda applications by tracing and analyzing user requests. Concurrency and scaling. It consists of provisioned concurrency and concurrency limits. Provision concurrency, it ensures that your functions can handle bursts of traffic by keeping specified number of function instances initialized and ready to respond. Concurrency limits, it allows you to specify the maximum number of concurrent instances to prevent overload. Integration with other AWS services, it consists of data storage, orchestrations, API gateways. Data storage integrates with services like Amazon S3, DynamoDB, RDS, etc. for data storage. Orchestration works with AWS Step Function to build complex workflows. API gateways combines with Amazon API gateways to create RESTful APIs. The last one, versioning and aliases. It has functioning versioning and aliases. In functioning versioning, it allows you to manage multiple versions of your Lambda functions, whereas in aliases, it enables you to create pointers to specify functions versions, simplifying deployments and rollbacks. So now let us see how Lambda is used in different sections. First is you can see file processing. In file processing, the image is taken and uploaded into a Amazon S3 bucket, where after it a Lambda is triggered. After then, a Lambda resizes the image and makes it available to your mobile, web and tablet sizes. Stream processing. In this, it uses Amazon Kinesis for the social media streams, which is loaded into the Kinesis in real time. So basically, it takes the most trended hashtag news and uses the real-time information where the Lambda is triggered, and the Lambda runs code that generates hashtag trending data, where then it is stored in the Amazon Dynamo database, where the hashtag trends database is stored, and it can be used for later social media trends data immediately available when a user is needed for the queries. Next one is mobile backend. Whenever a user gets a notification, this is how it works. They'll use the application known as Amazon API Gateway, where it triggers the Lambda, where the Lambda runs the code to look up the friend list and initiate status, update notifications, etc. Finally, after notifying the Lambda, then it stores to the Amazon SNS, where status get updated notification is pushed to your user's friend. Then finally, you'll get the notification where you can see your friend's status, which you can see in your mobile phones. So now let us see how we can create a Lambda function and get to know more about Lambda. Before that, if you want to know what is AWS and how to create an AWS account, please check out the link which is given in the description box below. Now you can see that we have opened a console homepage of AWS. So here, before creating a Lambda function, what you have to do is you have to create a S3 bucket. So I have already created an S3 bucket here, which is named as destination 216. So what I'll be doing is I'll be using this bucket to upload an image where it triggers the Lambda function so that it can resize the image according to your devices. So let me open the Lambda services. Click on Lambda. As you can see that in the right side of the page, there is an option called as create function. Before we can create a function, let's see how the Lambda works. So there is a sample program here to run a Lambda program. So there are different programming language such as .NET, Java, Node.js, Python, Ruby, etc. So let's run this program. As you can see that it gives the output as hello from Lambda, which is successful output. So if you want to know more about Lambda, click on next Lambda respond to event. So you can see that there is an image where Lambda is triggered every time the invocation is sent. So when we send an invocation as image in an S3 bucket, the Lambda get triggered and the image is resized so that you can view in your available devices. So when we use the number of invocations that we put it in the S3 bucket, it will cost you some money. So it depends on the number of invocations that are providing to the Lambda. So as you can see that if I provide n number of invocations, the cost is increasing here. So it depends upon the number of invocation that you use. So let me click on create function. As you can see that there are 4 types of plans that you can create a function. First is author from scratch. So here we'll be creating a function from the scratch. So use has a blueprint. So what it does, it builds a Lambda function from a sample code that is already present in this, which can configure presets from common use cases. So container image, what it does is it selects a container image to deploy your functions. Like image is uploaded inside a container when it is needed or called by the S3 bucket, the Lambda is triggered. Browser serverless app respiratory, what it does is it deploys a sample Lambda application from the AWS serverless application repository. So it has two types, public and private. Public, which can be used by any number of people, and private, it is for mainly when you're using in your organizations or companies, etc. So I'll be using author from scratch. So what I will be doing here is I'll be giving a function name as, let me say, a simple event. So you can choose your programming language such as Java, Node.js, Python, Ruby. I'll be choosing Python. There is an option called as permissions. So here you have to change your settings according to your needs. So I'm going to change my execution role as to create a new role from AWS policies templates, where a new role will be assigned to a Lambda function, so it get triggered when an object or an image or anything is uploaded in an S3 bucket. So after that, make sure to give a role name. I'll give the same role name. Make sure that when you're choosing the policy template, you choose S3 because we are uploading the image there and it gets triggered. Make sure you choose Amazon S3 object read only permission S3. After that, in advanced settings, let it be as default and click on create function. It may take some while to create a function. Please be patient. As you can see that a function is successfully created here. A simple event layer is given here, and as you can see that there is a code that is given from the Lambda itself. So if you want to use a different code, you can choose a different code. So I'll be using a different code here, which was present in the blueprint. As you can see that I have copied the program here. So before testing it or going further, make sure that you deploy the changes that you have made in your Lambda function. And after that, make sure that you add triggers so that when you call a function, it get triggered. So we are going to upload, as I told before, we are going to upload an image in a S3 bucket. So type S3, click on S3. So I am going to add this bucket named as destination 216. Event type, let it be as all object create event, then leave the rest to a default setting, and make sure that before clicking on add, to click on I acknowledge that using this S3 bucket for both input and output, which is not recommended, and that is configuration can use recursive invocation, increased Lambda usages and increased cost. Make sure that you have clicked on it and click on add. So as you can see that an S3 bucket is added here. After adding a trigger, make sure that you go to the S3 bucket, click on S3. As you can see that I have told before, I am going to use the destination 216 bucket, which I have created before. So click on destination 216 bucket. Make sure that you go to properties. Then at the end, you can see this, there is a table called as event notification. As you can see that there is an event notification here where you have created a Lambda function. See, destination type Lambda function. I'm here to make sure that event is created here. So we'll be again going back to the Lambda function. As you can see that there is already a Lambda function which one we have created before. So what we are going to do is make sure that you go to configuration. So when we go to configuration, go to permissions. So as you can see that there is an option here called as view policy. So you can view your code that you have given. Now go to code. Code will be present here, which I have used before to deploy it. As you can see that the code works and the Lambda is created and S3 bucket is also triggered. So before we run a Lambda function, make sure that you have uploaded an image or video in your bucket. So let's upload an image in our S3 bucket. So there is an option called upload. So what I'm going to do is I am going to upload this image here. So as you can see that the image is uploaded, image 2.png. So click on upload. As you can see that the image is uploaded successfully. Now go to the Lambda function. Click on simple event, the function that you have created. Next, go to the monitor here. As you can see that there are a number of invocations, durations and error count success. So what we are going to do is we'll see the before 5 minutes the number of invocations that we have given here, that is our image that we have uploaded in our S3 bucket. So it will take some time to show the invocations and durations the image has taken. Make sure that you be patient and keep refreshing it. Let me refresh it again. Please be patient, so because it will take a while to show that the invocations and durations that it is taken for the image. Let me refresh it again. Let me refresh it again. As you can see that here the invocation time has come here and the duration taken for the image to upload, it has also been shown here, and there is no error count here. The image is successfully uploaded. As you can see that the success rate is 100%. There is no error in the count. So if you want to know about the logs and other cloud watches, how it works after uploading your image, so let me show that. Click on view CloudWatch log. As you can see that you go to logs, in log group there will be already created a log here in the log stream. So you'll be having the log stream and the last event time that you have created your Lambda function. Make sure to click on log stream. When you click on log stream, as you can see that here the message shown as content type image PNG. This is the image that we have uploaded in our S3 bucket to trigger our Lambda. So this is how the Lambda functions work in an AWS service. It is used by mainly when we are sending our photos or images from one device to another device. It can be used in social medias, like the most trending reels that you get when you open your Instagram, and it can be used mobile backends, like when a person is or your friend is uploading a status, you will be notified about the status that is been uploaded, and you can view the person's or friends status according to it. This is how the Lambda function works basically. So if you want to delete the bucket or Lambda functions, go to S3. So this bucket is there. Click on it and make sure that there is an option called as delete. Click on it. Make sure that you type the correct bucket name that you have given here. Before that, make sure you empty the bucket. Make sure that you type the correct wordings without any spelling mistake, or else it will not consider it. So let me type it. As you can see that I have typed it correctly. So make sure you click on empty. As you can see that the image which we uploaded in this bucket has been emptied. So next, go to destination, again the bucket, click on the bucket, delete the bucket. So here it is also same, where you have to rewrite your bucket name and make sure that there is no spelling mistakes. As you can see that the option pops up for delete the bucket. Click on delete bucket. As you can see that the bucket is deleted here. So now let us see how we can delete a Lambda function. So you can see that this is a Lambda function that we have created, and where we have uploaded the image in an S3 bucket where the Lambda function is triggered. So now how to delete this Lambda function? Click on the simple event, then go to actions. There are options called as view details, test, delete. Click on delete. Make sure that you have typed the correct spelling here. Don't be clumsy. Click on delete. So you can see that the Lambda function is also deleted here. This was all about Lambda. Now to conclude this video, I would like to say AWS Lambda services makes it easier to run the code without owning the servers or managing the servers. It is easier to back up the data by using the Lambda function. To know more about this video, visit our course, the link to which is given in the description box below now. With this, we have come to the end of this video on AWS Lambda tutorial. I hope you like this video. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!